Hello all, welcome to the subject of microcontroller. I am Professor Pinakshi Pancha from Electronics and Telecommunication Department, Parvatibai, Yanna, Muji College of Engineering, Wagholi, Pune. So in today's lecture, we have to see programming environment topic. So what is the programming environment topic and what are the study case, how the program will be developed, how we can edit and write the program, how we can compile it, how we can run it, and how we can simulate it. We will see in this part. So let's see. There are a basic development tool which is used for programming purpose. Especially in a microcontroller, there are two types of tool. First one is software development tool and second one is hardware development. First one is software development tool and second one is hardware development tool. First one is software development tool, second one is hardware development tool. So the software development tool which comprise of these things, what are those? The software development tool which comprise these things, what are those? First one is assembler. Second one is editor. And third one is compilers. And fourth one is simulator. And last one is debugger. The another one we can say IDE. IDE is nothing but integrated development environment. So these are involved in the software development tool. In the hardware development tool, there are some tools are those which comprise of, let's see what are in the hardware development tool and what are the users and applications and what these tools will be provided as task. We will see one by one. So hardware development tool consists of emulator, second one is demo boards, and logic analyzer. Digital storage oscilloscope, you can say short form DSO, is nothing but digital storage oscilloscope, and logic probes. So let's see one by one. First, see the study of software development tool chain. And an integrated development environment, IDE, is a software that allows the user to develop an application. So So it will having it provides a source code editor, which is we can also say text editor, compiler and interpreter, and debugger, emulator, programmer, and simulator. So an IDE comprise every software tool that is needed to develop an application program of 8051. So which is used in a microcontroller and in a PIC 18XX family of the microcontroller, MATLAB IDE is used. See here, there are a different IDE for different software. The MATLAB software IDE used for PIC 18 family microcontrollers. And that software IDE used for that 8051 microcontroller, which is a different. So let's see one by one. What is the task of editor? So which is contained in the software development tool IDE. So what is the task in an editor? We will see. It is a program that allows a programmer to enter the editor our programs. So which is editor is one of the program. So that program will allow us to write program there, or we can edit our program in this editor. An editor is basically which is a software program, and it helps the user to create a file that contains an assembly language statement. So if we want to do any, for example, we are going to writing a program for interfacing LED or analog to digital converter, any peripheral device, if we want to interface with our microcontroller to control that operation, or which that device operate according our according. So we have to write a assembly language program for operation of that particular device. So this editor will help to write the program there. Then we can edit our program and we can sense our control signal using this editor. And the examples of editor used for assembly language program are WordStar, Edit WordPad, and Notepad. These are the editor for this assembly language program. The job of the editor is to store the ASCII code for the letter and numbers in a successive RAM location. And the typing of the program is over, and this file is stored on a floppy or hard disk. This file is called as a source file, and an ASM extension is given to it. The source file is then proceeds using an assembler. The microchip MATLAB IDE has a text editor that allows the user to enter the program and also edit them. So this is the task of the editor. Let's see what will assemble will do. See here, each assembly level instructions. We have seen the task of editor, simply which allows this editor allow to write a program there, and we can edit our program there. So this is the editor. Now let's see what is the task of assembler. So each assembly level instruction has a mnemonic. For example, the instruction move. So such kinds of instructions have some mnemonic which represents the assembler. An assembler is a program which translates the assembly language mnemonics into corresponding binary code, and the assembler reads the source file then more than once. So this assembler what can do here, see here, we will write such kind of instruction move a comma hash 30. So such kind of instruction we are writing or editing in the editor. So after that, assemble what it will do, assemble reads this editor, and these codes instructions will converted into the binary form, because the computer cannot understand these instructions, the words meaning. Computer can only understand the language of zeros and ones only. So in editor what we are, this kind of instruction we are writing in the editor, and assembler what it will do, it will read these instructions and it will convert into binary form. It will zeros, binary is nothing but zeros and ones. So this is the task of assembler. The assembler first read the source file of a program, then it is determine the displacement of data item, offset of label, etc., and put these information into the symbol table. Then it produces the binary code for each assembly language instruction and detect syntax error if any. Then it insert the offset etc. calculated edit earlier. So what it will do after if we writing some instruction there, so it will read the instruction. If there is any error, so it will detect that syntax error. Syntax error is nothing but there is a predefined word move. So we are going to transferring for data. So this command we are going to use. So if I am writing like move a comma hash 30, this is a way of writing the instruction. If any error I have provided or I am any mistake now made in while writing the program, so that will identify those syntax error. So an assembler generates a two file, namely the object file, and second one is assembler list file. So the object file is given to extension and object file, whereas the assembler list file is given to that extension. There are two types of files. There is one is object file, second one is object list file. So first file will be given object file and second one is the object, whereas the assembler list of file is given to that extension. It contains the binary code of the program instruction and information about the address of the instruction. And list file, which contains the assembly language statements, the binary codes for each instructions and the offset of each instruction. Any typing of syntax error are indicated in the assembly listing if we take a printout of list file. So this is the operation of file generation. There are two types of file will be generated. One is the object file and second one is the list file. So object file, what it will do, it will contains a binary code. So inside the object file, it contains the binary code of the program instruction and the information about the address of the instruction. So in a list file, it contains assembly language program statement and the binary code for each instruction and offset of each instruction. So this is the file generation of the file generation by using an assembler, or assembler inside the file will be generated like that. So another one task is there, error detection and correction. The assembler is capable of only finding the syntax error. To check if our program is working, we have to test and run the program. The error indicated by the assembler should be edited using the editor. So after we are writing, so here we are writing a program into our program editor. So assembler, what it will do, assembler read those programs or instruction and it will try to finding any syntax error is present in those instructions or not. So it will check our program is a working or not, and we have to, and it will have to test the run the program, and it will allow the editor to edit the program if any error is present there. And this edit assemble loop should be executed till all the errors are corrected. So checking the error and allow to editors. So this loop will be repeatedly working until all the errors should be corrected. So for the microcontroller family PIC 18 this family, the MATLAB will be support for writing a programs and these assemble operation, everything. So all the source code can be translated into object code there, and also provide object first file and need for debugging which emulator system. So it has a macro assembly capability and supports the decimal and hex octal source as well as the listing format. So uh, things will be available in a MATLAB. So these facilities will be available in a MATLAB because the BIC 18 family is using this MATLAB IDL. So let's see linker. So what is the linker? We have seen now editor and assembler, and we have to see what is the operation of linker. So linker is a program which is used for joining many object file into one large object file. This is the main task of the linker. What it will do in a program, we have written many multiple subroutines and loop, everything we have written. So linker, what it will do, so it will check the program and which will use for joining many object files into one large object file. So when a large program is being written, and it is always advisable to break and it into the small module so that each module can be separately tested and debugged. Then finally link their object models together to form a large working program. The display routine can be kept in the library file and linked into other programs when it will require. The linker produces a link file which contains a binary code for all the combined models. The linker also produces a link map file and it contains the address of all the linked files. It is an important to note that the linker does not assign absolute address. It only assigns the relative address to the program starting from the 0. And it is relocatable. The linker with MASM or EASM, which produces the link file with a .exe extension. So whatever the file is there, it will link the file and it produces a single large file, and that will stored in the or read that by using a extension .exe. So the microchip, those are relocatable linkers and which is having a compiler also, and it can link relocatable objects also. So let's see what will do compiler now. The compiler is a program that translates the high-level language source program to the machine-level language program. This is the operation of the compiler. This is the operation of compiler. The compiler is a program which is also itself a one of the program. What it will do, it will translate the high-level source program into machine-level program that machine can easily understand. The program written in a high-level language is called the source program, and the program that is compiled on the machine is called as the object code. The compiler translates the source program into relocatable object module. The object modules are linked by the linker, and locator load the complete program in a memory where it can be executed. However, the drawback of using the compiler is that if any error is detected, we need to correct the source program and repeat the compilation process. This is the operation of compiler. Next, one thing is there, we have to see cross assembler and cross compiler. So what is the operation of this? We will see now. The special feature of the cross compiler is that it is not written in the same language that is used by the microcontroller that execute the machine code and that is generated by the assembler. What are the features of these cross assembler is nothing but what is the program written in an editor which will be using this language of that source code language, and then after it will convert, execute those language into the object code and which will be generated by the assembler. The cross assembler is usually written in a high level language like a Fortran, C, Pascal, etc. So that makes it machine independent. An assembler that runs on one type of computer and assembler the source code for a different target computer is called as a cross assembler. For example, an assembler that runs on an Intel 86 machine and generates a object code for Motorola. This is the one example of this cross assembler, and the another example is that the assembler may have written a program for 8086 in a C level language, and then the assembler may be executed on some other machine like a Motorola 6800. So this is the cross compiler assembler operation, like that the core source code is written in a one form and which will going to compute in a different environment. For this PIC18 microcontroller family, the cross compilers and cross assemblers generates an executable code that can be placed in a ROM and EPROM and flash memory. So this compiler what will do? For example, in this PIC family, what it will do? The source code will be converted and it will be placed. The code should be in executable form and that will be placed in a memory. So this is the cross assembler and cross compiler operation. Now let's see the debugger. So what is the debugger? Debugger is a software tool that is used to detect the source of the program or script errors by performing step-by-step execution of the application code and viewing the content of code variables. If the program is directly accessible from the microcomputer and does not need any external hardware, then we can use a debugger to run and test the program. So basically, the debugger is a program which permits the user to load the object code program into the system memory and execute the program and debug it. And which is also permits the change in the register contents, memory location and return the program. With the help of the debugger, we can stop the program execution after each instruction so that we can check or alter the memory and register contents. In other words, we can put the breakpoint into the program and execute the program from one breakpoint to other. Debugger is possible to examine the register and memory content after the partial execution of the program between the breakpoint, and which can also use the debugger to check the correct program till all the errors are corrected or not. So the most IBM PC type computers at basic debugger comes by the default. So MATLAB IDL allow the user to debug the program using the source file. For this PIC18 family, which is uses a microcontroller, so which the MATLAB IDL will be used, and they make the debugging easier and allow the user to see the contents of the register, the memory location as the program is executed. So this is the operation of the debugger. So now let's see emulator. So what is the emulator? So this emulator is a hardware development tool, and which is used to test and debug the hardware and software both of the external system, such as a microcontroller based system. And emulator is a combination of hardware and software both, and which consists a multi-wire cable that connects the host system to the external system. So this cable, the software of the emulator allows the user to download the object code program into the RAM into the external system, and which is being developed. So link the debugger and the emulator also allows the user to load the program to be tested and run the programs and check and modify the content of the various register and the memory locations, and also insert the breakpoints. And as each instruction in the assembly language program is executed, and the emulator as if takes a snapshot of the register contents and activities on the address and the data buses and the state of the flag register. The emulator stores this data as trace data, and it is possible to take out the printout of the trace data so as to analyze the result produced in the program or the step-by-step basis. A simulator is often used to execute a program, and that has to be run on some inconvenient type of the computer. For the example, simulator are usually used for debugging a microprogram. Now see the what is the operation of simulator. Simulator is used for executing the program, and that has to run on some inconvenient time of the computer or inconvenient, and which is also used for debugging the microprograms. Since the operation of this computer is simulated and all of the information about the computer's operation is directly available to the programmer, and the speed of the execution of the simulation can be varied as per the user's wish. The simulator may also be used to interpret fault trees or test logic designs before they are constructed. The many video games are also simulator, and that are implemented expensively. Simulator is one of the software package, we can say like that. It is also one of the software package and that functions like a hardware without acquiring the hardware. The 8051 microcontroller simulator gives the users an 8051 environment on the PC, and it which performs the functions of 8051 microcontroller and also performs the simulation of the different peripherals, and that are used with the microcontroller and microprocessor both in any application. So this is some of operations of the simulation, and we can also say which provides the facilities that helps the user to find the logical error and also learn about the initialization of different peripherals and also get insight of the microcontroller functioning. So we can see in a simulation, and also act as a direct placement of costly 8051 microcontroller kit. See, the microcontroller kit is a very costly. How the simulation, how the output will be going to performing, we can see and understand by using simulation easily. So this simulation is very, this simulator is replaced that microcontroller kits that it will the microcontroller kit simulator is very costly. So, and also shows the internal registers and entire memory and peripherals on the monitor. And the simulator also supports the breakpoint and single tapping facilities that help the user to debug their program. So in the simulator, we have to see the computer configuration required to run the simulator. What are the computer configuration to run the simulator in our computer? We have seen simulator, we have seen that. Now in the simulator, now we are going to see the computer configuration required to run the simulator. To install and run the simulator in our computer. So what the configuration should we need? So let's see now. The 8051 simulator run on the PC. The requirement of the PC is simulator requirement. First one is RAM. We require RAM of minimum 512 KB. So the PC should be contain the RAM with minimum 512 KB. Then it should have DOS compatibility. Then also should have IBM Mono CGA ECA and VGA or compatible monitor. Compatible monitor. Then also should require 2 disk driver. These are the computer configuration should be required for run and simulator purpose. So features of the simulator, we will see some of the features of simulator. What are the features? Which is very easy to operate. Allow the simulation of the peripherals. Provides continuous display. Provides continuous display of the system. Provides continuous display of the system. And the program can be easily modified. Using this simulator, the program can be easily modified. Then The core can be viewed and the corresponding instruction makes it easy to understand and the logic of the program while the program is executes. And also powerful debugging tool with a different high level debugging facility. This is the main feature of this powerful debugging tool. This is powerful debugging tool which is having high debugging facilities. And also checking the software before the hardware is available to the user. Also checking of the software before the hardware is available. So this facility is also there, and it has the ability for the user to construct the screens that shows the various part of the 8051. The powerful debugging tool, and each screen is made up of separate window that display the internal CPU registers code and the data memory areas. The content of any location in the code, ROM and the internal RAM and the external memory can be changed as the program executes. The IO port may be simulated by changing the value of the port SFR, and interrupts are simulated by striking the function of the keyboard. The executing a simulation and the screen set file is loaded into the simulator first. Then the file is allowed by the program that is written in the object code format. The program is then executed and using these simulator commands. The rest of the program counter 000H and single step the program and free run the program and free run until the breakpoint is reached and stop the free run. So these are the simulators. So this is enough for the day. In the previous lecture, we will see the how the mode of simulator will be works and the hardware debugging tools. And the other things in an emulator and how the programmer development board, these things we will see in a hardware development tools. And another one is a 4 logic analyzer, and this is a small topic, and we will see in the next lecture, and we will continue with the next unit, parallel port interfacing. This is enough for the day. Thank you.